This is the third example on confidence interval for population means. So the heights of people have a standard deviation of 11.5 centimeters. It is required to estimate the mean height of people. Okay, so we're talking about the mean height with a 95% confidence to within plus or minus 0.4 centimeters. What sample size should be taken in order to achieve this estimate? Okay, so we're looking to make sure our confidence interval is very, very narrow. So there's a difference of plus or minus 0.4 in it. So using the formula, now you'll see our formula is usually x minus 1.96 and x plus 1.96, the standard deviation over the square root of n. Now all we are worried about for this particular example, we don't know the mean and we don't really care about the mean. All we are concerned about is this bit here. Okay, we want to make sure that this part is going to be equal to 0.4. You would have 0.4 on one side and then the one with the minus on it as well. It is a difference of minus 0.4. Okay, so we only need to worry about one of them. So we're going to get our 1.96. Standard deviation we know is 11.5, and that is going to be equal to the square root of n, because n is what we're actually looking for here. And then you're going to solve it just like you would an algebra equation. Okay, so what we're going to try to do here is to get rid of the n first of all. It'd be much easier if we got rid of that. Okay, we can multiply these two things by each other, so it's 1.96 by 11.5 all over the square root of n is equal to 0.4. Multiply both sides by the square root of n, and also you can, we'll do it in separate steps, but we can divide by 0.4 as well to get rid of this on this side. So we've got 1.96 by 11.5, and that's all divided by 0.4, and that is going to be equal to what the square root of n is equal to. So then if we got what the square root of n is equal to, so that means the square root of n, if we just put all the other stuff into the calculator, it's 56.35. And then we square both sides, so n is equal to 3175.3. Now, so we're asked what sample size should be taken in order to achieve this estimate. We can't have a decimal point in that, we're going to have to round it up. We need a sample size of 3176 people. So that's the minimum sample size in order to achieve that target. Okay, so for this final example, this is as hard as it's going to get for these kind of ones. Generally, you're going to get one of the easier types, like example 1 or 2, but this is the hardest one. On the basis of the results obtained from the random sample of 100 men after from a particular district, the 95% confidence interval for the mean height of the men in the district is found to be 177.22 centimeters to 179.18 centimeters. Find the value of x, the mean of the sample, and rho, the standard deviation of the normal proportion from which the sample is drawn. Okay, now we're talking about the means, we're talking about the mean height, so you know it's going to be this formula here you're making reference to. Now the reason why I've written this particular form is because we don't know all of these values. We're actually looking for this one and we're looking for this one. When you're looking for two unknowns, you're going to have to make simultaneous equations out of it. Now, in order to do that, we know that the minus version, so x, the mean minus 1.96 by rho over the square root of, and now we know we're talking about a sample of 100 men, so it's over the square root of 100, which is 10. And we know that that is equal to 177.22. And then the other one, the mean plus 1.96 by rho over, we can even just call it 10 this time, and that is equal to 179.18. Now, thinking of simultaneous equations, so this is my equation 1, this is my equation 2. If we added these two lines together, you can see all of this is the same. They're going to cancel each other out, so we're left with 2 of this plus these two together, which we get as 356.4. And then if we divide both sides by 2, we will get the mean is equal to 178.2. So that's the sample mean. And then to get the second one we're looking for here, looking at these values, now you could sub our mean back in and solve one of them. But there is a quicker way if you want. If you want to solve it the quicker way, what we can do here is if we actually take these two lines away from each other, so essentially we're adding these two together. Okay, so basically multiply this one by minus 1. You'll be able to add these two lines together, so you're left with no sample means at all. You have 2 by 1.96 by rho over 10, and then that is equal to the difference between these two. So the difference between these two is 1.96. So then if we divide by 1.96 on both sides, we have 2 rho over 10 is equal to 1. And then I multiply by 10 on both sides. So I've got 2 rho is equal to 10, and then rho is equal to 5. So the standard deviation is equal to 5 centimeters.